Hi guys, here's video 2-13 to be watched Tuesday 10/18, and the homework that corresponds to it is page 20, only number 1, just one problem. Okay guys, so the theme of this lesson is chain rule inside of other rules. So what other rules do we know? Power, product, and quotient. So today you're going to see chain rule inside of product rule and then quotient rule. Now when I initially designed this lesson, I added for us to find the slope of the tangent line to the graph at a certain value. Well, what's another name for the slope of the tangent line? The derivative. So I wanted you to plug in a value after finding the derivative, but I think we're just not going to do that. Okay, so I crossed both part B's out. So differentiate the function below. What I see here is a product of two functions. Okay, so that means I'm going to be using the product rule. But those functions in themselves are compositions of other functions, so I'm going to have to use the chain rule. In a situation like this, guys, I really recommend setting up your rules with the brackets first. That's going to really benefit us. So I'm going to set up the product rule with brackets. Okay, so I'm going to have 4 brackets total. Okay, there's the first two, plus in between them. Prime on the first bracket, prime on the last bracket, because we're going to be taking the derivative of what is inside of those ones. And then, so if I look here, there's where the product is. So my first function is this, my second function is that. Okay, so I'm just going to put them in the brackets where they belong. So I've got 6t squared plus 5 to the third. Okay, that's the first function. And then the second function, t to the third minus 7 to the fourth. And then I just repeat what I wrote down. 6t to the second plus 5 to the third, t to the third minus 7 to the fourth. Okay, so the brackets with the primes on them are the ones where I have to take the derivative of what's inside. And if I look here, so I got to take the derivative of this. This is a function within a function. So I have to use the in and out chart. I have to use chain rule. So I'm just going to go in, out, like that. And I'm going to look forward to the other function that I have to take the derivative of. This is another composition of functions, another function inside of another. So I have to use another in and out chart for the chain rule. So this one here, my inside function is 6t to the second plus 5. And what's the function that it is inside of? Blank to the third. Okay? Now I just did that, so I'm kind of in the mode right now to fill out these charts, so I'll go over and fill this one out. T to the third minus 7 is inside of blank to the fourth. Okay, now I'm ready to use the chain rule, derivative of the inside, derivative of the outside with the old inside plug back in. So the derivative of this inside function here is 12t. Yep. And then the derivative of this outside function is 3 blank to the second. I just used power rule, but I'm plugging the old inside back in. So 6t to the second plus 5. Okay? So that was the derivative of this first one. Now this function gets just carried down. So t to the third minus 7 to the fourth. I'm carrying down that plus sign. Okay? I'm not taking the derivative of this, of what's inside this bracket, so this just comes down. 16t to the second plus 5 to the third. Okay, and now I'm going to use the chain rule, derivative of the inside, derivative of the outside with the old inside plug back in. So this is 3t to the second times 4 blank to the third, power rule there. Old inside plug back in, t to the third minus 7. And that's it, guys. If you wanted to just leave it like this, you'd be fine. I like to have my coefficients out front and, you know, things in, like, I don't know. This order kind of bothers me. So I'm going to write for you, you know, how I would feel satisfied with it at the end. So g prime of t. So in this first term here, I'm going to just do 12 times 3 which is 36t, 6t to the second plus 5 to the all to the second, t to the third minus 7 all to the fourth, plus I've got 3 times 4, that'll be 12, t to the second, and then 16t to the second plus 5 to the third, t to the third minus 7 to the third. Okay, so that is the first example. So we had chain rule inside of product rule. Now we're going to do chain rule inside quotient rule. Okay, so here we have a quotient, and okay, so I'm going to set up the quotient rule with brackets, but I'm only going to do the numerator. Okay, and then at the very end, I'm going to remember that I need to do g squared in the denominator. Okay, so let me be clear here. This is numerator of s prime of t, dot, dot, dot. Okay, so I'm just going to figure out the numerator first. So it's going to be, the numerator that you get with the quotient rule looks very much like the product rule, except with a minus instead of a plus. Okay, and again, this is all in the end going to be over g squared. Okay, so f is the numerator of my original function. So I'm going to convert it to, I'm going to convert the radical to exponential notation so I could use the power rule later. So I have t to the third minus 8t all to the 1/4. Ooh, sorry, you can't even really see that, but that's a 1 to the 1/4 power. And then, so t to the 10th, try to write the numerator more clearly, t to the third minus 8t all to the 1/4, okay, and then t to the 10th. Now, guys, if you feel like you've got this, go ahead of me or speed this up. But, so I have to take the derivative of what's inside this bracket. That's a function within a function. I need an in and out chart so I can use the chain rule. I'm going to take a look at the other bracket with the prime on it and see if I need the chain rule. I don't. That's going to be a very simple power rule, so I'm not going to do an in and out chart under there. So this one, inside I have t to the third minus 8t. The outside function is blank to the 1/4. Okay, and I'm ready to take its derivative. So derivative of the inside function is 3t to the second minus 8. That's a binomial, so I need parentheses around it. If you get a monomial, like in the first example, we got a monomial here, I didn't need those parentheses around it, but I did it because, I don't know, parentheses never hurt. Okay, here they are necessary. And then this one here, I do power rule. So 1/4 blank to the 1/4 minus 1. 1/4 minus 4/4 is negative 3/4. What goes inside the old inside? Okay, so just like that. T to the 10th just comes down. Okay, but there wasn't a prime on that bracket. Minus, okay, this just comes down, not taking the derivative there. T to the third minus 8t to the 1/4 times, this is a simple power rule, 10t to the 9th, okay? That's just the derivative of the numerator. Now I'm about to write my final answer, guys, and I'm not going to forget that the denominator has to be g squared, with t to the 10th squared. Okay, so what do I have? Oh, okay. So, in the new, this is going to be kind of messy, but so here, for this first one, I'm just going to write the coefficient first, 1/4, t to the 10th, 3t squared minus 8, t to the third minus 8t to the negative 3/4. Okay, so that's the first term written with the coefficient and the monomial coming first, minus coefficient, monomial, and then this thing, all over t to the 10th squared. And guys, I've really been emphasizing how much you don't have to simplify, but if you wanted to say t to the 20th, that's wonderful. Okay, there's that, guys. You only have one problem for homework. Okay, so give this a shot. Page 20, number 1, and I will see you soon.